All right, welcome. In this video, we're going to be working AP Pre-Cal Homework 01, and it's all about solving equations. And so hopefully we're just going to get you started with something that's at least somewhat familiar. So we're starting with some equations that have fractions in them. And so, we see fractions, we have different denominators. We need to get those to the common denominator. So with A, I'm seeing a denominator of 2 and a denominator of 4. I think probably the easiest way to go would just be turn everything into a denominator of 4. So I'm going to need to take each of these objects and multiply it by the right form of 1. So I've got 3x over 2, and I need to have a denominator of 4, so I'm going to multiply by 1. 2 over 2, that's 1. Minus 4, well, that's going to be 16 over 4. I don't think we really need to multiply both sides. We can just think of 4 as 16 over 4 equals 5 halves. That's 10 fourths minus 7x divided by 4. And now, I don't know, you might remember this from Algebra 2. We're just going to clear out the denominator. If everything's divided by 4, we just multiply both sides of the equation by 4 and we kill off the denominators. Okay, so really what I'd just be doing is I'd be saying 2 times 3x, that'd be 6x, minus 16 equals 10 minus 7x. And then we're just going to try to get all the x's on one side, everything that doesn't have x on the other side, and basically solve for x. Well, you know how. So we're going to add 7x to both sides. So I'll have 13 total x's minus 16 equals 10. I'm kind of running out of room, so maybe I'll just think about adding 16 at the same time. So 13x equals 10 plus 16 is 26. If 13 times x equals 26, that feels to me like x is going to need to equal 2. Or you can think about it, you're going to divide both sides by 13, and 26 divided by 13, however you like it. Okay, B, 7 over 12 equals x divided by 3 minus 5 over 6. I think that the most obvious common denominator there would be 12. So I'm going to keep the 7/12 equals, let's see, okay, multiply by 4 on top and on bottom to get that 12 there. So it would be 4x over 12 minus, okay, 5/6. I would need to multiply the 5 and the 6 by 2 to get 12ths. So I'd have 5/6 is equivalent to 10 over 12. Okay. Maybe this one I'll keep the 12ths, in case you were like, if the first step I took over here, or the second step I took over here to just clear out the 4s, that wasn't familiar to you. I'll just show you how you don't necessarily have to do that. What we could do, try to isolate the x's. We're going to get rid of this, so we're going to do the opposite, add 10 over 12 to both sides. So if I have 10 over 12 plus 7 over 12, that would be a total of 17 over 12. And that would be 4x divided by 12. And, if we really wanted to, we could kind of cross-multiply and multiply 12 times 17, but I don't know what 12 times 17 is. I could figure it out if I had to, but I think there's probably a better way, right? I think now would be the good time to multiply both sides of this equation by 12 and say that means 17 is equal to 4x, and that can divide both sides by 4. I'd say that x is going to equal 17 divided by 4. Right? Can't reasonably expect in this course that all of the solutions to all the problems are going to be whole numbers. That's not going to be a reasonable expectation. They could be fractions, they could be decimals, they could have a square root in them. We'll deal with all that. Okay, this one, if we see like this type of multiplication with parentheses, we're probably best off distributing first. That's going to be my advice, especially in this beginning of the course time. So what we're going to do is distribute the 2 over the 3x and the minus 1. Still have that minus 6 there, and then distribute the 4 over the x and the minus 2. So I'm going to say that that's 4x minus 8. Okay, to kind of isolate. Or maybe I'll combine these like terms. That's basically what we should do. So negative 2 and negative 6 combines to be negative 8. So 6x minus 8 equals 4x minus 8. Okay, I didn't know we were having any of these on here. Make sure I didn't make any errors here. Nope, I'm thinking, let's see what we've got here. So if I added 8 to both sides, I'd see that 6x equals 4x. Oh, pardon me, I was thinking wrong. This one is going to have a solution. This is not going to be very interesting. So I'll add 8 to both sides and say 6x equals 4x. Subtract 4x from both sides. That'll be 2x equals 4x minus 4x. That'll be 0. And if 2 times a number is equal to 0, that means that number has got to be 0. And the way that can work out. So we'll do the next one pretty much the same way. Start by distributing the 3 over the 2x and the negative 4. It's going to equal 5 multiplied by the x minus 3. So 5x minus 3 times 5. Subtract the 5x over here. And then I'll get rid of this minus 12 by adding 12 to both sides. So x is going to be negative 12 would be negative 3. All right, number 2, f is going to be a function defined by f of x equals 5 minus 4 times 6 minus x. So if we're looking over here and we're thinking about f is type of thing, it takes a number and it basically subtracts 6 minus that number, multiplies that by negative 4, and then adds 5. Okay, so it's kind of a strange function, not the way we would normally write it, but we can work with this. We say f of 0, what we're doing is we're replacing x with 0 here, so we've got to replace x with 0 everywhere we see it in the formula. So I'm going to say f of 0 is going to be equal to 5 minus 4 times 6 minus 0. Anywhere we see x in the formula, we're replacing it with 0. That's what it means, like f of x, f of 0, f of c. If we saw f of c, we would just replace x with c. Why we would want to do that in this class, but you'll see later on why I might want to do that. Okay. At this point, this is just arithmetic. So negative 4 times 6 is negative 24. So I've got 5 minus 24. That's going to be equal to negative 21. Dang. Let me think about that. Nope, that would definitely be an arithmetic error. 5 minus 24 is negative 19. Find the value of x for which f of x equals 0. All right, so we've got a formula for f of x. That's 5 minus 4 times 6 minus x. And that needs to be equal to 0. And so I'm going to subtract 5 from both sides. If you want to, you can distribute, and I think that's what I'm going to suggest you do because it looks like it wants to be distributed on. Say negative 4 times 6 is negative 24, and negative 4 times negative x would be positive 4x, and that's going to equal negative 5. Okay, so if I add 24 to negative 5, it's basically the same thing. I'm not going to make the same mistake twice. I'm going to say that's going to be 19. So 4x is going to equal 19. 24 minus 5, yeah, that makes sense. And then divide both sides by 4. So x would be 19 divided by 4. Find the value of f of negative 3. Same thing as before. We're just going to plug in negative 3 there. Whoops. F of negative 3 is going to equal 5 minus 4 times 6 minus negative 3. So that'd be a total of 9. 5 minus 4 times 9, so 5 minus 36. Okay, well, if it was 5 minus 35, I'd have negative 30. So I'm feeling like this is going to be negative 31. Yeah. Now, find the value of x for which f of x equals negative 3. So it's just like before, we're just going to replace the 0 with a negative 3. So 5 minus 4 times 6 minus x is going to equal negative 3. Maybe I'll distribute first this time. 5 minus 24 plus 4x equals negative 3. And then maybe I'll get rid of the 5 and the 24 together, rather than trying to do this arithmetic that I keep stumbling over. Maybe I'll say, I'll add 24 to both sides, and I'll subtract away the 5. I'm just kind of doing the opposite here, and that'll be equal to 4x. And negative 8 plus 24, that'll be 16. And just kind of keep working it around until you get something that's a little bit nicer on the arithmetic level. Then I'll divide both sides by 4, and I'll see that x is going to need to equal 4. All right. So number 3, solve the equation, show the work that leads to your answer. Okay, so we're going to isolate the x squared, and then we're going to probably take the square root of both sides. That's what the plan is. But first, we kind of need to do the opposite of the natural order of operations. We're going to need to get rid of addition and subtraction first. So we're going to subtract 4 from both sides. And we'll divide both sides by 3. So we've isolated the power of x. Then we're going to take the square root of both sides. And I probably told you in class, when we take the square root of both sides of an equation, what we're doing is taking the square root of x squared. And that feels like x. But if you really think about it, it's not just x. It's the absolute value of x. If you take the square root of a square of a number, it's always going to come back positive. And, I went into why that's true before, so you can go back and check out the video if you need more on that. But what I'm going to say is now, absolute value of x is equal to the square root of 9, which is 3. And then if the absolute value of a number is 3, that number is either 3 or negative 3. And, if you just want to say, I take the square root of both sides of an equation, I'm going to use the plus minus, that's great. That is what you're going to do. But I think it's important that you understand why you do that mathematically, rather than just remembering, okay, I'm supposed to do that, because that won't last as long. Okay, this one over here, same story. We're just going to subtract 5. Oh, no. It's going to come up with the same solutions. Pardon me, and that was not the most clever problem I ever wrote, but it'll be all right. Okay, so I subtracted 5, I got 36, I divide 36 by 4, and I get x squared equals 9 a second time. I don't think I need to go through the same process. Same equation, going to have the same solution. So x equals 3, x equals negative 3. Let's move on. Right, x minus 3 squared minus 2 equals 14. Now, rather than trying to square this binomial and solve it some other way, we'll do that next time, maybe. Let's just try to solve this one directly. So let's just kind of do the reverse order of operations. Let's add 2 to both sides. X minus 3 squared equals 16. Okay, square's on the outside, so I kind of need to take the square root right now. And I'll do that. I'll say, all right, well, x minus 3 is going to be plus or minus 4. Now, I could say absolute value of x minus 3, but that's really, we're not talking about solving absolute value equations here in this class right now, or really at all. That's not really part of AP Pre-Cal. So I'm just going to say kind of plus or minus 4 here. And I'm going to say x equals 3, add 3 to both sides, plus or minus 4. So if I take 3 plus 4, that would be 7. And if I take 3 minus 4, that would be negative 1. So 7, negative 1, those are my solutions. This one looks very similar. X minus 2 squared equals 25. I subtract the 4 first, take the square root, plus or minus 5. And then I will add 2 to both sides. Okay, if I have 2 plus 5, that would be 7. If I have 2 minus 5, that would be negative 3. And now here we've got another function that we're going to be considering. The function g of x is x plus 3 squared minus 4. Okay, x-intercepts on the graph of g. And x-intercept, I'll draw the diagram for you this time. It's going to be a place where y equals 0. And g of x, that's just code for y. So what we're going to do is we're going to set the thing equal to 0. If you were in my Algebra 2 last year, you did a lot of practice on this. Find the x-intercept, find the y-intercept. You might be thinking to yourself, that was pretty much all we did last year. And I wouldn't say that, but it was close, right? We did a lot of intercept finding. We're going to do a lot of intercept finding in this class as well. So what we're going to do is set the thing equal to 0. And then start solving. So add 4 to both sides. Take the square root of both sides, and I get x plus 3 equals plus or minus 2, because I took the square root of 4. And then I'm going to subtract. So it would be negative 3 minus 2, or negative 3 plus 2. And these are my two x-intercepts. But I don't know if you remember, I hope you remember from Algebra 1 or Algebra 2 that like a quadratic, which is what we would get in the graph of x squared, something related to x squared, it can have two x-intercepts, right? It's a parabola, it can run into a horizontal line twice. That's what we're seeing right here. The y-intercept on the graph of g, that's just going to be, okay, right over here, a point where x is equal to 0 on the y-axis. So we're just going to plug in 0 for x and say, all right, g of 0, wherever I see x in the formula, I'm going to replace it with 0. So that's 0 plus 3 squared minus 4. Okay, so that'll be 3 squared, 9 minus 4. The y-intercept would be y equals 5. And if you were asked for the coordinates, you might say x is 0 and y is 5. For these, you might say x is negative 5 and y is 0, x is 0. Is it possible for a point on the graph of g to have y 10 and give a reason for your answer? Okay, that's something that in this class, since it's the first day, I'm going to point out you need to be very careful about. Because if you see this on like a quiz or a test, this kind of prompt, give a reason for your answer, show the analysis that leads to your conclusion, justify your answer, that means you're going to be graded on your work, okay, or on your reasoning. And so you're not going to just be able to say, no, it's not possible. Spoil the surprise, it's not going to be possible. No is not going to be a suitable answer. You would probably get no credit at all for that because you didn't guess right in that situation. Okay, so if we have y coordinate negative 10, let's think about that. So negative 10 would equal g of x. So it would be x plus 3 squared minus 4. Okay. Then if I added 4 to both sides to try to isolate the square, I'd have negative 6 equals x plus 3 squared. And that's not going to return me a real answer. Maybe you remember from Algebra 2 that there are kind of solutions to this equation. And we will talk about that even in this unit, but not today. And as far as a point on the graph of g, the graph is like y versus x, where x and y are both real numbers. So I'm not going to be able to solve for x and get a real number because I'm going to have to take the square root of negative 6. And there's no real number that I can add 3 to, square it, and get a negative number. Because you take any real number and you square it, it's going to be positive. It can't be negative 6. So, no. My reason could be this. I would be okay with this. This is just not a solution or an equation that has a real solution. But I would say x plus 3 squared is not equal to negative 6 if x is a real number. On to the third page now. Yep, this would be number 5. And we're going to, okay, we're back to solving more equations. I remember when I made this homework, I tried to spice it up. It's like, give you a function, have you solve some equations. Give you another function, have you solve some more equations. But really the focus here is solving equations, getting back into the kind of math state of mind, shaking off the rust. I'll be honest, I haven't done any of this stuff either. Maybe a little bit more recently than you. I went and did some stuff over some math things over the summer, but really, it's been a while. So we're shaking off the rust, getting back into the swing of it before we get talking about something that's new to you. So first thing, I feel like I got to distribute here. It looks like it wants to be distributed. So I'm going to multiply 3 times 7/3. 3 is like 3 over 1, so it'd just be 7. Plus x to the 3 over 9. Well, if I multiply by the 3, it'll be x to the 3rd over 3. I'm going to kind of just hold on to that. I'm going to subtract 7 from both sides. Oh, except I lost my divided by 3 and had no reason to lose that, but okay, x to the 3 over 3 equals negative 5. Yeah. And then I'm going to multiply both sides by 3 to isolate the x cubed. X cubed equals negative 15. And then I'll take the cube root of both sides. So x is the cube root of negative 15. Okay, now I'll point out that this is a real number. You can take the cube root of a negative number. It just comes back negative, right? Because if you take a negative number to the 3rd power, it's going to be negative. And so there's some number out there that if I cube it, it's equal to 15, positive 15. And take that number, make it negative, and that would be a cube root of negative 15. And we don't need to go any farther than this. I don't believe. And definitely not for the first day homework. Okay, 2x to the negative 2 equals 18. This is good. We're going to start by dividing both sides by 2. Okay. And then what I'm going to do is I'm going to take kind of like the opposite power of both sides. So I need to think about what kind of number would I multiply by negative 2 to get 1? And that would be negative half. So what I'm going to do, and I'll be just like really explicit here, x to the negative 2 to the negative 1/2 is going to equal 9 to the negative 1/2. And now I am, I don't know if you remember, but I am going to be taking the square root of both sides of an equation, so I should probably have a plus or minus here. But I'm going to kind of do that at the end and try to like hit you on a reasoning level rather than an algebra level, because it seems like a little much for the first day. So this is going to be x to the 1st. And, okay, a negative exponent, what I'm trying to get you to remember from last year, is that turns a number into a fraction. So if I have 9 to the negative half power, that's like getting a fraction 1 on top, 1/2 on bottom. Okay. And the 1/2 power, that's like the square root, because it undoes the square. So the square root of 9 is equal to 3. So I've got 1/3 here. But the issue is, I'm actually proposing that x could also equal negative 1/3. And the reason why is if I take negative 1/3 to the negative 2nd power, we'll turn it into a fraction first. It'll be like negative 3 squared, that's positive 9. And I double it, and that's positive 18. So negative 1/3 is a valid solution to this as well. Both of these work. But as far as on a quiz or test, especially when we're getting started and on the year, if you only give me the positive solution, that's going to be all right. Okay, I'm mostly concerned with you being able to like execute the steps and do the algebra more so than remembering like the fine print details of algebra 2. That's why it was the fine print. All right, so over here, same story. Isolate the power of x. I'm going to add 2 to both sides. Then we're going to multiply both sides by 5. So that'll be 50 equaling x squared. Okay, I do like this because we're going to take the square root of both sides and we'll get plus or minus the square root of 50. Now, unlike in AP Calculus, this is something I'm going to have to be used to as well because I've taught AP Calculus for a long time and nobody's ever taught AP Pre-Cal before. The kind of standard for our presentation of our answers is a little different. In AP Calculus, this would be a perfectly fine place to stop. But on the free response section of the AP Pre-Cal exam, this is not good enough. We have to simplify radicals when we can. So I've got that square root of 50. And hopefully you see that and you see the factor of 25 in there. You think of 50, it's 2 quarters. And 25 is a square number. So what we're going to do is we're going to split that off into the square root of 25 times the square root of 2. Because that's how square roots work. And the square root of a product is the product of the square roots. So square root of 25, that's 5. So I've got plus or minus 5 root 2. And this is how far we need to go in this class. We do need to simplify our radicals. And if that's something you need extra support on, you just let me know. I've got worksheets from last year, from last time I taught geometry or whenever. We can get you the help you need if you need support on simplified radical form. Because I promise, you can do it. You might just not have had the need to do it last year. Like if you were in my Algebra 2 class last year, I didn't really realize this was going to happen in AP Pre-Cal. And I told people, sometimes it's okay to leave it at square root 50, especially in the context of solving an equation. But we're called to do a little bit more this year, so that's all right. Okay, I think, we could distribute here, but then we'd eventually need to divide by 3 to get the x on its own. So what I think I'm going to do, since 3 does divide 21, I'm just going to start by dividing both sides by 3. So I'm going to have x to the 2/3 minus 2 equals 7, because I divided both sides by 3. Now I'm going to add 2 to both sides. And then I'm going to take both sides to the 3/2 power so I can get x to the first, because that's always what I'm looking for, is just x to the first. So I'm going to say x equals 9 to the 3/2. Okay. And if you say, I feel like I'm probably going to be saying this a lot throughout the year. But if you were with me last year in Algebra 2, my advice to you was deal with the denominator first. Okay, this pen didn't really keep well over the summer, but we're going to deal with the denominator first to keep the numbers manageable when we have a fraction exponent. So the denominator, that's some kind of radical. If the denominator is 2, that's going to be a square root. So what this is the square root of 9 taken to the 3rd power. And the square root of 9 is 3. 3 to the 3rd is 27. So I've got x equaling 27. Okay, and let me think about this. This is another one where I probably am going to want negative 27 as well. Because if I square it, like plugging x equals negative 27 back in there, yeah, if I square it and then take the cube root, that'll go back positive, so that it would be the same. So this one does have both solutions, but again, this is not a gotcha type situation where it's like, oh, I'm looking for you to make that error. I actually don't care if you make that error, because I'll work with you and we'll get there over time. I really want you to get to 27. That's what I really want. And if you're struggling here, that's something I can work with you on. It's not a big deal. Okay, find the x-coordinate of the point on the graph of h where y equals 18. Oh, there was punctuation on this, it's very faint. All right, so y equals 18, h of x, that just stands for y. X. Okay, this one probably should have gone before any sort of solving with x to the negative 2, but live and learn. Maybe I'll make a note for next year to reorder these problems. I'm going to start by dividing by 24. So 18 over 24, that's also the type of thing that we're going to need to be able to simplify in this class. So might as well simplify it right now. I feel like these both have 6 in them. Yeah, 6, 12, 18, 24. I'm big on counting by numbers. I think that was just kind of how I learned how to do arithmetic in elementary school. So if I say 6, 12, 18, 24, 3, 24 was 4, it's going to be 3 divided by 4. Okay, so if I'm for x, I think to myself, what power do I need to take this to make it x to the positive 1? So I'm going to multiply negative 1 by a negative 1 to get positive 1. So I'll say x is equal to 3/4 to the negative first power. And the negative first power takes a fraction and it flips it. Or it takes a whole number and it turns it into a fraction with numerator 1. So if I do that, that's just going to give me 4/3. Find the y-coordinate of the point on the graph of h where x is equal to negative 2, gladly. Okay, so that would be h of negative 2. And wherever I see x in the formula, I'm replacing it with negative 2. So 24 times negative 2 to the negative first power. Now, let me tell you what's not going to happen here. This negative up here is not going to affect this negative down here. It's just that's the difference between a negative number and a negative exponent. A negative exponent brings in fractions. A negative number, you know about negative numbers. You've been knowing about it for a long time. So what we're going to do is say, maybe I'll just look at this guy right here, this 2 to the negative first power. Okay. What that really is 1 over negative 2 to the first power. So I'm just going to be dividing by negative 2. So I'll have 24 multiplied by negative 1/2. That will be negative 12. And then explain why the graph of h of x has no x or y intercept. I think it would probably be easiest for me to talk about the y-intercept first. That would be x equals 0. Well, h of 0 would equal 24 times 0 to the negative first power, which, on first glance, like, okay, I don't really see anything wrong with that. But if you think about what 0 to the negative 1 means, it means 1 divided by 0. So this would be like 24 divided by 0. But division by 0 is bad news. It's undefined no matter what. In this course, we'll see that like 0 over 0, sometimes there's like a little bit more work that we can do with that. But whole number divided by 0, that's game over. There's nothing we can do with that. That doesn't exist. Okay, so the y-intercept is undefined. What you learned last year is you're sitting on a vertical asymptote. But I'm really not interested in getting into that right now. We'll talk plenty about that in this course. For an x-intercept, that's going to be where y is equal to 0, and so h of x equals 0, so 24x to the negative 1 equals 0. That kind of tells me that 24 divided by x is equal to 0, but think about that. Take 24 and divide it by a number. The bigger that x gets, the closer 24 over x gets to 0. But it can never equal 0, because the only way a fraction can equal 0 is if the numerator is 0 while the denominator is non-zero. Okay? That's on the numeric level. On an algebraic level, if you multiplied both sides by x, you'd have 24 equaling 0x. But 0x has got to be 0, so that's like basically saying like 24 equals 0. That doesn't have a solution either. So this is why we're not having it. You're either dividing by 0 or looking to solve an equation that has no solution. So that's why there's no x or y intercept. All right, solve the equation, and these have got some radicals in them. Okay, that'll be good. That's probably good that we do that. Get rid of those. I don't know how often. I doubt we'll have to deal with this type of equation very frequently in AP Pre-Calc because radical is not really one of the things we're tasked with working with. But you never know. Especially with this being a brand new AP class, and they're still adding questions to AP Classroom right now. We're going to get a couple of new practice tests released in January, I think. Who knows? And so I'm kind of taking the approach, better safe than sorry. And this was something that y'all were really good at last year in Algebra 2, solving radical type equations. So I figured let's just leverage that and give you some more practice on it, just in case it does come up. So what I'm going to do, I've got this square. If I had other stuff on the outside of the square root, I would work to isolate the radical first. That was kind of the guiding principle of solving radical equations in Algebra 2. Isolate the radical, take to the appropriate power, then solve the rest of the way out like you're familiar with. So in this one, I'm going to square both sides. And when you square both sides of an equation, you don't need a plus or minus. You just need to remember to check your solution. Okay, that's the thing you got to remember. There's always something to remember when you square both sides or square root both sides. It's just going to be different depending on which. If you square both sides, what can happen is you can end up with an extraneous solution. And so you have to take your answer and check it and make sure it's not giving you something that's really false. And I don't think that will happen on this one. Maybe it'll happen in here. Again, this extraneous solution is not really the point of this course. So we're going to square both sides. 3x plus 1 equals 100. No, this one's going to be great. Subtract 1 from both sides. 3x equals 99. Divide by 3. X is going to equal 33. But since I did square both sides of the equation, I do need to check and to see what's going to happen. I multiply 33 by 3. That's 99. 99 and 1 is 100. Square root of 100 is 10. Beautiful. Okay, and, just pointing out, like I said, and I'm sure I said in the lesson, I'm being honest, I have not delivered the lesson yet. Let's go ahead and get started yet. But I know if I'm delivering this lesson, I'm going to be reminding you that when we see the square root here, especially written in ink on the piece of paper, that means the positive square root. That does not mean plus or minus. Okay? We mean the positive square root of this equals positive 10. So that's going to be possible. All right, so then over here, the same story. We're just going to isolate the radical first. So we're going to add 4 to both sides. 2 of these square roots of x cubed is going to equal 54. And then divide both sides by 2. That is equal to 27. Oh, okay, this is interesting. I don't think I noticed the subtlety of this problem when I was typing it up. I think I stole it from somewhere else. But, we could square both sides, but I don't know what 27 times 27 is. Right? I could go get a calculator. I could consult with my phone. But as I told you, you're not going to be allowed to use a calculator or a phone on the quiz or the test, so we need to figure out a way to deal with this. And what I would point out is that, this is like the 3/2 power. Or you could kind of switch it so that it's the square root of x cubed. Same thing. And then I can take the cube root first. And that'll keep these numbers more manageable, like I'm talking about. Because 27 times 27, that's not manageable for me. I don't know what that is. And then taking the cube root of that, I can tell it's a cube number because it's got 27 in it, but it's just not, right? Let's take the cube root first, bring this down to 3. Square root of x is equal to 3. Square both sides. Okay, so I got to check my answer. X equals 9. Okay, so the square root of x cubed, well, maybe I'll take the square root first. 3 to the third is 27, times 2 is 54, negative 4 plus 54 is equal to 50. I feel good about it. Over here, 3 cube roots of x squared minus 2 equals 10. 3 cube roots of x squared equals 12. Divide both sides by 4. Cube root of x squared is equal to 4. Now at this point, I think these numbers are manageable regardless. I do need you to know in this class that 4 to the third is equal to 64. And I also need you to know the square root of 64. But if you wanted to, you could take the square root of the 4 first and then cube that. You're going to get 8 no matter what. I think the most obvious thing to do would be work from the outside. I don't know that this step right here was this one to here was all that obvious. So I think that y'all would be most likely to try to cube both sides. So that would be 64. And then we'll take the square root of both sides. That's where the plus minus comes in. And I'm going to say x equals plus or minus 8. Okay? And the reason why the plus or minus, if I take that negative 8 and I go back in here and I square it, I'm going to get positive 64. And I take the cube root of that, I get 4, and it works out. Okay, feel good about it. But this was not the type of equation that I was going to need to check my solution necessarily. Okay, I might have to pull back on that. You should always check your answer, right? Especially if you are like really needing to be certain about the truth of your solution, you should check it. But as far as like needing to check your solution because of the possibility of extraneous solutions, that's not on here. Both sides of the equation, we didn't take both sides of the equation to an even number power. On this one, we've got a fraction. So we're just going to try to clear out the fraction, multiply both sides by the denominator. So 2 will equal 54 times the cube root of x. I think I meant for that to be x cubed in the denominator, but it's all right. And so what we're going to do is we are going to divide both sides by 54. So 2 over 54, that's like 1 over 27. And that's equal to the cube root of x. Yep, because what I'm going to need to do now is cube both sides. Actually, I do think that this is maybe still within the realm of arithmetic I can do. Because I know quite a few powers of 3. So what I'm going to do is I'm going to take both sides of the third power. So I need 27, 27, 27. No, I don't have that. Because 20 times 20 is 400 times another 20 would be 8,000. Yeah, I don't have that. You know, in the interest of like not pulling out a calculator, not using technology on this, I'm going to say this is going to be a safe place to stop because on an arithmetic level, this is too much for me to ask. Okay, really, I think what I meant to do is make this x cubed. So we took the cube root of that, and it would be 1/3. It's probably what I meant to do, but clearly it's not what's printed on your homework, so we're just going to go with that. And 1 over 27 to the third, if you wanted to call it 27 to the negative third power, whatever you want. It's gonna, really, I'm just happy you're still with me working this far into the homework, right? Practicing. So that's what we need. All right, so suppose f of x is equal to this type of function where k is a constant. If f of 12 equals 4, so that's going to give me an equation that I could probably use to find the value of k. So f of 12 is equal to 5/6 of 12 plus k. And they told me f of 12 was equal to 4. So this is an equation that I'll be able to solve. And so, well, if I do 12 divided by 6, that's going to be 2. 2 times 5 is 10, rather than trying to hit a 12 with a proportion like that. That's like the type of place I might make an error. Okay, so I guess I don't really need that equals there. 10 plus k equals 4. K is going to be negative 6. So now I know that f of x is equal to 5 over 6x minus 6. It's plus k, so plus negative 6. And then we're looking for f of negative 6. And 5/6 of that is going to be negative 5 minus 6, and that's going to be negative 11. So that's the value of f of negative 6. Okay, and this is a problem type to see coming back again later. Okay, hey, here we go again. You know, like, same problem type. I think the actual setup is a little different. Asked you for a little bit of distribution, but it's all good. We can work with that. So f of 2 equals 4. So 4 is going to be whatever I get when I plug in 2 for x, and that will help me find the value of k, which I will then use to find f of negative 2. So 4 is going to be 3/4 of x. Nope, 2 plus k. I didn't, recording this in my room, didn't bring my usual eraser type thing, so you're just going to have to forgive me on that. 2 plus k plus 1. Okay, maybe we can work with this, right? Maybe we'll subtract 1 from both sides. 3 equals 3/4 of 2 plus k. Now I'll multiply both sides by 4. divide by 3, subtract 2, and now I've got it. Okay, all right, now that I know k, I can say, all right, well, f of x is equal to 3/4 of x, and then add 1. Okay, what is f of -2? It's going to be 3/4 of 0 plus 1. Any number times 0 is going to be 0, plus 1 would be equal to 1. Okay? And then, okay, we've got 2 more problems, and they're kind of like applied geometry, and so you know what I'm going to suggest. I'm going to suggest you draw a diagram, right? If we're talking about a rectangle has length and width, okay, well, let's just do that. Okay, length, I don't know, maybe that's height. X plus 3 squared, width is 5. So that means this is 5, and this is also x plus 3 squared. And this diagram might not be drawn to scale, but that's all right. So the perimeter is 50. So I'm going to add all this stuff together and get 50. So 50 would equal 5 plus 5, plus this x plus 3 squared, plus another one. Okay. So if I have 2 of these, and I add them together, I'd have 2 times x plus 3 squared. So 50 is equal to 10 plus 2 times x plus 3 squared. And then I'm going to subtract the 10, kind of just like getting at that x by doing reverse order of operations, get rid of addition and subtraction, then get rid of multiplication and division, and then we'll deal with the parentheses and exponents all the time. So subtract 10, divide by 2, take the square root of both sides, so x would equal square root of 20, which, let's do that work preemptively off to the side. Square root of 20, I feel like there's that 4 in there, 4 times 5. So I'd say 4 times 5, square root of 4 is 2. So I'm going to have that plus or minus 2 root 5. I'm going to take the square root of both sides. Equals x plus 3. And so my options for x are going to be -3 plus 2 root 5 and -3 minus 2 root 5. And both of those would be valid because that wouldn't cause me to have a negative side length in my rectangle. But again, you know, even if it did, I'm not that concerned with that. I just want you to be able to solve for x, especially on the first day of school. That's really the idea, is just getting back into the practice. All right, last one. You know, we've made it this far, 37 minutes. Actually, that's probably what I expected it to take. Same story. But maybe for the sake of my diagram, I'll call this x minus 1 squared, and that 4. Perimeter is 80. So I've got 80 equaling 2 4s, so it'd be 8, plus 2 of these. I feel like that was supposed to, this one was supposed to work out a little better. Let me make sure. 10. Yeah, I don't know. I must have messed up somewhere. It'll be all right, though, right? I hope. 20, 40, 50, yeah. I don't know. So, back to this one. We're going to solve for x. We're going to subtract 8 from both sides. Yeah, that's way better. Divide both sides by 2. 72 divided by 2, that would be 36. Take the square root of both sides. I'd get plus or minus 6 equals x minus 1. And I'd say x equals 1 plus or minus 6. So if I had 1 plus 6, that's x equals 7. If I have 1 minus 6, that's negative 5. But if you look at it, if I was to like subtract 1 from negative 5, I'd have negative 6, and I square it, that's a width of 36, or a length of 36. So I have 36, 36, and 8. That adds up to 80. I'm satisfied. That's all the problems for this homework. Thanks for watching. Thanks for signing up for the class. Like, I'm really excited for a good, solid year of pre-cal. A lot of good, hard work, and really an opportunity to get a college credit and really improve yourself in math and give yourself a leg up on AP Calculus. So thanks for watching.